Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
So in order to be able to do our ionic equations, we need to know first which substances actually split up when they dissolve. So you should know two things. One, ionic compounds, as long as they are soluble, will split up when they are dissolved. So for example, sodium chloride will split up into its chloride ions and its sodium ions. And then the other one is acids and alkalis, and we should know that because we know when acids are dissolved, they release positive hydrogen ions, and when alkalis are dissolved, they release negative hydroxide ions. How do we split something like potassium sulfate into its ions in one of these equations? So potassium sulfate, we should know that's made up of our potassium ions, which have this +1 positive charge, and that's because potassium is a metal in group 1, so it loses an electron in its outer shell to form its ion, and sulfate was one of our complex ions that we needed to know. So we need to know that that has a -2 charge. Then what we need to be able to do now is just like what we do for our ionic bonding, think about how many of these two things there must be. Right now I need to balance my positive charges with my negative charges. I've got two negative charges from my sulfate and only one positive charge from my potassium. So there'll be another potassium ion. So I can write the formula as K2SO4 here, which means if I break it down into its ions, I had two of those K plus ions, and then I had one of those sulfate ions. And just be careful here with sulfate and other complex ions, just because there's an SO4 at the bottom. If there were four of these ions, it would be a bracket round the SO4 and a number below that. Okay, that 4 doesn't mean there's four of them. There's four oxygens in this sulfate ion. Okay, so there is just one sulfate ion and two potassium ions here. How do we know the ions that make up a compound like NiCl2? So nickel, we don't know its charge because it's a transition metal, so I can't figure it out from my periodic table. But we do know the charge of a chloride ion, and it's always just got a negative charge. Because it's in group 7, it will gain one electron to fill its outer shell, so it's always just -1 negative charge. So what I can sort of say here is that I have two of these chloride ions, so my overall negative charge here is -2, and I need that to be balanced by the positive charge coming from the nickel. So at the minute, I've got -2 on my right hand side, so I need +2 on my left hand side, and there's only one of these nickel ions, so it must be that my nickel has a charge of +2. So if I were to break that compound up into its ions, it would be nickel +2 plus 2 Cl minus, okay, because I had two of those chloride ions. Right, time to turn a balanced equation into an ionic equation here. So this is my equation at the minute, and the first thing I'm going to do is notice that my titanium here, on my left hand side, the charge on that titanium ion is being balanced at the minute by two nitrate ions. That's why I've got the NO3 brackets, the two round the bottom there. That actually means that there are two of those nitrate ions. Or on the right hand side, equally, I have got my titanium being balanced by two chloride ions. Now, both of my chloride and my nitrate, it doesn't matter which one of those two things I look at, they both just have a -1 charge. And since there are two of them, overall, that is a -2 charge. Now, what that is going to tell me is that my titanium must have itself a positive 2 charge to be bonded to those two things. Okay, now we can look at how all of these things split up into the ions. So we need to factor in those big numbers at the front as well when we do this. Let me write out the whole equation first, and then we'll go through it stage by stage. So first bit here, this bit is going to be broken up into the titanium and the nitrate, and I have 3 of those titanium ions, which I just managed to figure out from the way that it was bonded, that have this positive 2 charge. And how have I figured out that I have 6 of these nitrate ions now? Well, okay, I know that I have 2 of them balancing each one of these titanium ones. So that's that number 2 of the bracket at the bottom of my nitrate there. But also I have 3 altogether of these titanium nitrates. So in total, that's actually 6 of these nitrate ions. Okay, now breaking up my AlCl3. So I'm breaking that up into aluminium and into chloride ions. Now, again, I have to think back to my ionic bonding to be able to tell you that aluminium's in group 3. Okay, so it's a metal, which means it's going to lose its 3 outer electrons, and therefore it's going to have a positive 3 charge as an ion. And I know that my chloride ions have the negative 1 charge. It's a non-metal, it's in group 7, and it gains 1 electron to have a full outer shell. So that's where that plus 3 and minus 1 come from. But then how do I know how many of them I've got? Well, I've got 2 AlCl3, so I've got 2 of those aluminium ones, and then I've got 6 of the chloride ones here. This is what I mean by factor in these big numbers at the front, because I have got 3 at the bottom there, Cl3, but then I have got that times 2, that number in the front, to give me 6 of these chloride ions. Okay, then I have got this TiCl2 here, but it's a solid, okay? So it's not going to have, therefore, broken up, dissociated, dissolved into its ions. And then finally, AlNO3 here. So I've got 2 of those aluminium ones, and I know this time that it's 3 plus. Again, exactly the same as when it was bonded to the chlorine, and then 6NO3 here. Again, for a similar reason, I've got 3 of the nitrates, but then it needs to be multiplied by that big number at the front. Right, now I can cancel some of these things out, the spectator ions. So I'm looking for ions that are the same on both sides. So I've got 6 nitrate on both sides, cancel those out, and I've got 2 of the aluminium ions on both sides, so I can cancel those out as well. So I am left with this equation here. And that is my final ionic equation.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
So remember, when you're doing these ionic equations, you can only split up solutions of ionic compounds or acids and alkali solutions. Some things you can't split up, like for example, you see H2O, that's just water. You can't split that up into ions. Or the example that we just did there was a solid that had formed, and that won't split up into its ions. Otherwise, it would have AQ for aqueous to tell you that it would be soluble. Be careful to factor in, yes, those big balancing numbers at the front. So that's what we were talking about on the last slide. We actually had 6 nitrate ions. Just be careful to factor those numbers in as well. Spectator ions may appear multiple times on each side, so you need to keep your eyes peeled. So for example, on one side, you could have 6Cl, on the other side, you could have 2Cl and 4Cl. You need to make sure that you can cancel both of those things out, even if they're split up on one of the 2 sides.